Okay, so for part one of homework 2-2, we've got a couple multiple choice questions to start us off. So hopefully these questions are pretty easy, but go through them anyway, just make sure you get them right. So shown below, they give us several different diagrams, in which case is the person slowing down and turning to his right. So slowing down would obviously be, my last choice over here would make a lot of sense. And by the way, my letters got all out of sort, but that's okay. My last option would definitely be slowing down, but he wouldn't be changing direction. He wouldn't be turning in this case, right? So it's not that one. This person would definitely be turning to his right, but he wouldn't be slowing down. So the correct option here was option B, and that's because part of the acceleration goes to the person's right. So if the person is walking downward, right, then they're facing downward. So his right would be this way, and then he's going to be slowing down because part of the acceleration works against him. So in any case, option B is the correct one for this one, and hopefully that was easy enough. For question 2, also hopefully very easy, right? Which arrow best represents the direction of the acceleration at this point down here? Now they do tell us that it's moving in the clockwise direction, but to be honest, it doesn't really matter, because regardless of whether it's going off tangent this way or off tangent this way, if the direction is changing, then that acceleration better be pulling towards the center of the circle, right? So the only option that fits that one is option D. So again, hopefully those first two multiple choice questions were pretty easy to get through. Okay, so the correct answer for this, if you want it, is 18.2, or the square root of 333. Obviously, if you got that, awesome. If not, if you need to see it worked out, I will work it out. Okay, so they tell me object A has a position function given by this. So it tells me basically I've got a horizontal position component and I have a vertical position component, right? When we see the I and J, that's what we need to be thinking is this is my delta x and this is my delta y, right? That's what those functions are giving me. And I know those get pretty busy sometimes with all the units in there, but really all this is it's 3ti, right? Again, indicating the horizontal one, plus 1t squared j. So try to look past the units if you can, and just focus on what the variable part of that function is. And similarly, right, do the same thing for the second position function. It's just 4t in the horizontal direction, and then it's negative 1t squared in the vertical direction. So they ask me, what is the separation, what is the distance between these two objects at 3 seconds? Well, if I want to find their distance between them, I want to find out where they actually are at 3 seconds. So all I'm going to do is I'm going to plug in 3 to both of these position functions, right? So this would be 3 times 3, so 9i, plus 1 times 3 squared, so again 9j. Okay, so I really want to think about this as the vector 9, 9, or even better yet, the point 9, 9, and we'll see why in just a second. Similarly down here, again at 3 seconds, this would be at 4 times 3, so this would be at 12i, and then this would be negative 9j. So again, I'm thinking of this as the vector 12, negative 9, or better yet, the point 12, negative 9. Because this is telling me where its x position is and where its y position is, and this is telling me where that x position is and where that one is. Okay, so then if I want to find the distance between these, right, this is truly just going back to algebra where we can do the distance formula between any 2 points. Fun fact, by the way, the distance formula is really just a Pythagorean theorem, right? There's nothing to it other than it's just finding the difference from x to x and then finding the difference from y to y. Okay, so if I want to find then the distance between these two locations, again, all I'm doing is I'm finding my change in x squared plus my change in y squared, which is like the two legs of my right triangle, which is why this is the Pythagorean theorem. Okay, but in any case, finding that distance formula, again, my change in x in this case would be 12 minus 9 squared, and then my change in y would be, keep in mind it is 9 minus a negative 9, or vice versa, it doesn't matter. But it should be either a negative 18 or a positive 18 that we are then squaring, so it doesn't matter. So then when I calculate that, that's where again I get 333 underneath the square root, or if you want to approximate that, at about 18.2. Now it does just ask for the distance, right, between them. It doesn't ask for the displacement between them. So I don't have to worry about any type of angle. If it did ask for the displacement, I would simply graph these 2 points on a graph, right, and then sketch the right triangle with hypotenuse between them. Okay, so I'd sketch my point at 9, 9, I'd sketch my point at 12, negative 9. Okay, so if this was maybe my xy axis or whatever, 9, 9, 12, negative 9, and then I would simply build my right triangle between them and find my angle involved. But this question as it stands hopefully wasn't too bad. Question 4, also hopefully not too bad. So they give me the position function here. So they're giving me this whole mess again. Try to look past the craziness with all the units involved, right? So ignoring the meters per second and the meters squared per second. This is just saying that my horizontal position is given by the function 2.0 meters plus 5t. So again, that's my horizontal piece. And then my vertical piece is given by the position 3.0 minus 2t squared. Right? So I'm looking past the units and I'm just looking at my function. They ask me what is the speed of the object at 2 seconds. Well, if they give me the speed, right, to find the speed I don't want the position function, instead I want the velocity function. So if I want to find the velocity function, well, I simply have to take the derivative of my position function. And the beautiful part about this is I simply do the derivative of each of these functions on their own, because we know that the horizontal measurements and the vertical measurements are separate. So anyway, finding the derivative of this is easy enough, right? The 2.0, and keep in mind I'm dropping the parentheses, they're not really there. The derivative of a constant goes away, and then the derivative of 5t is just 5. So I end up with a velocity of just 5, and then over here I end up with, so the 3 goes away, and then I pull the 2 out front, so negative 4t to the first j. So then they do specify what is the velocity, what is the speed, I should say, at 2 seconds. So then to find that, right, there's nothing to plug in, so my velocity at 2 seconds, well, there's nothing to plug in for my horizontal component. My horizontal component is always 5 no matter what. But my vertical component would be negative 4 times 2, so negative 8. So then my components of the velocity at 2 seconds are 5 in the horizontal direction and negative 8. So I do want you guys to be comfortable translating this into a triangle. I go right 5 and I go down 8. But in this case they actually just ask me for what is the speed. They don't even ask me what is the direction. Right? So all I really need to do now is find the hypotenuse. So then finding the magnitude, the speed, I'll go ahead and say the speed by just the absolute value, just the magnitude of the velocity vector here. Just again the Pythagorean theorem, right? 25 plus 64 and then the square root of that. So either the square root of 89 or 9.43 meters per second. Okay, so all this question really entails is going from position functions to velocity functions, and again, just getting comfortable with all the vector notation that this chapter likes to use. Okay, so there's nothing real crazy here, nothing you guys can't handle, just getting comfortable with the new notation. Similarly, question 5, right, very, very similar, except this time they asked me to find the acceleration at 2 seconds. And so again, they give me my function, they give me my position function, and I think is it maybe not quite the exact same, but very similar to what we just had, right? So this time my position, my horizontal position is 2 plus 3, and then my vertical position is 3 minus 2t squared. Okay, so that may have been the exact same function we have. But if I want to find the acceleration, right, I'm just going to do two derivatives. So my velocity would be 3i, right? Again, the constant function going away and then bringing that out front. And then over here, my derivative of this, again, the 3 would go away and it'd be negative 4t j. So again, my vertical component, my horizontal component. Then my acceleration vector would once again be the derivative of that. Well, at this point, the 3 would go away because it's just a constant. So I actually don't have any horizontal acceleration, right? So my a of x, my horizontal acceleration, is 0, which I knew because it was moving at a constant 3 meters per second if I look at my velocity function. Whereas my vertical acceleration would be just negative 4, right? So I have a constant acceleration of negative 4. Okay, so it does specify at 2 seconds, but to be honest, it doesn't matter. My acceleration vector for this particular function would always be negative 4 because it comes from 0, negative 4, which is just a vector going off not to the right but downward, negative 4 meters per second squared. So the acceleration vector, and it does again just ask for the magnitude of that acceleration vector, would be negative 4 or even just 4 meters per second squared. right? The negative would just indicate it's going downward. Anyway, making sure we're getting comfortable with this type of question, again, also very important for us to do. So question 6, obviously very similar to question 5 that we just looked at. They give me the position function, but this time they don't give it to me in vector format, right? I could rewrite this as vector format by just saying negative 12t plus 4t squared I, and it would look exactly like the functions we were just given, and then plus yada yada yada, right, for my y function j. So I could rewrite that as vector format if I wanted to, but they went ahead and broke it up separately, which maybe makes it a touch easier for some of us to look at. But part A here again asked me for what is the acceleration of the frisbee, give the magnitude and direction. Now you'll notice that they don't specify a time, but I also want you to, before you even solve this question, hopefully you start to notice this, right? If the position is a squared function, that means the velocity would be a linear function, because that would reduce down to 1, and then the acceleration would be a constant that doesn't involve t, right? So the reason that they don't specify a time is because the acceleration is going to be constant for both my horizontal and vertical directions, and so they don't need to specify a time. It's just going to be a given number for the horizontal component and a given number for the vertical component. So anyway, working through this problem, all I need to do is find my derivatives, right? So my velocity function in the x direction would be the derivative, which is negative 12 plus 8t. Hopefully at this point you're getting very comfortable with those, right? My acceleration function in the x direction would be the derivative of that, so it just ends up being 8, right? It ends up being 8 meters per second squared, and again, notice it's a constant at 8. Similarly, the y direction, right? My y velocity function would be 10 minus 6t, right? Not 3, but the 2 comes out. And then the acceleration function would be a negative 6 meters per second squared. Okay, so it doesn't matter at what instant we're looking at this. The acceleration is always doing the same thing. And so again, in this case, the acceleration is going off 8 meters per second squared to the right, and it's going down 6 meters per second squared. And so for part A, they asked me to find the magnitude, magnitude and the direction, measuring it from the positive x-axis. Well, here I'm again just finding the hypotenuse. It's actually a nice 3, 4, 5 triangle, right? It's a nice Pythagorean triple. So the magnitude of the acceleration actually just ends up being 10, just through the Pythagorean theorem. So 10 meters per second squared. And then the angle with respect to the positive x-axis here, it would be just that theta. So theta equals tangent inverse of 6 over 8, or 3/4 if you prefer. But in this case, I get 36.9 degrees below the x-axis. So my final answer for part A, my final answer for A, would be the acceleration is 10 meters per second squared at, again, 36.9 degrees. And I would truly just say below the positive x-axis. Okay, so that's my answer then for part A. Hopefully that wasn't too bad. And then for part B, they asked me to find the magnitude of the velocity at 2 seconds, and they asked me to do so accurate to the nearest meter per second, which actually many of you guys will notice rounds the answer off pretty significantly. But anyway, the good news about part B is you've actually already set it up by finding your velocity functions, right? If I ask you to find the velocity at 2 seconds, well, all I have to do is find my x velocity at 2 seconds, which is easy enough. It's negative 12 plus 8 times 2, so 16. So negative 12 plus 16 would be 4 meters per second. So there's my velocity in the x direction, and then here's my velocity in the y direction. Again, 10 minus 6 times 2. So negative 2 meters per second. So they do once again ask for the magnitude. In this case, they don't even ask me for the direction. So building my right triangle there, I'm going off to the right 4 meters per second. I'm going down at 2 meters per second. Notice because I drew it down, I dropped the negative. So all I have to do is find the hypotenuse. And here's where I said it's kind of odd that they have you round it to the nearest meter per second. Because when you find the hypotenuse for your velocity, when you find the magnitude of your velocity vector, it actually ends up being about 4.47. So when you round it to the nearest meter per second, it's actually back to 4 meters per second, which kind of makes that look like a goofy right triangle, but that still works. So anyway, we will stop part 1 here and we'll pick up questions 7 and 8 in the next part.